Hello everyone, I'm Hema Malini, Assistant Professor, Department of Physics from Madurai Sivakasi Nadar Pioneer Meenachi Women's College. Today we are going to discuss about semiconductor in solid state physics. So first do know solid state physics. Solid state physics is the study of rigid matter or solids through methods such as solid state chemistry, quantum mechanics, crystallography, electromagnetism, and metallurgy. It is the largest branch of conductance matter physics. Solid state physics studies how the large scale properties of solid material results from their atomic scale properties. Thus, solid state physics from a theoretical basis of material science. Along with solid state chemistry, it is also has direct application in the technology of transistor and semiconductor. And what is valence band? The energy band involving the energy level of valence electron is known as the valence band. Lead is the highest occupied energy band. When compared to the insulator, the band gap is semiconductor is taller. It always the electron in the valence band to jump into the conduction band to receiving any external energy. What is insulator? Do not allow the current to flow through it with the do not allow the current to flow it through with the application like glass conductor. Allow the current to the flow through it the application of voltage like copper. And what is semiconductor? A semiconductor is a material whose conductivity properties lie between conductor and insulator. Semiconductor example are silicon, germanium, gallium, arsenide, etc. A material in which the conduction and valence band are separated by a small energy gap. Small energy gap. A small amount of energy is required to free electrons by moving them from the valence band into the conduction band. Semiconductor behaves as an insulator. Conductivity in the range of 10 power minus 3 to 10 power minus 6 volts per meter. And this is a conduction band conductor, and this is the semiconductor, this is insulator. This is a conduction band and valence band. Conductor is a material which easily conduct the electron flow, and the insulator, but when it comes to insulator, which is not a good conductor and it does not allow the electron flow in it. And semiconductor, here the semiconductor lies between the both conductor and insulator. So, and this is a band gap. This is a small energy gap. The small energy gap is equal to EF. This EF is the Fermi level. Fermi level is the 50% of conduction band and valence band gap. And now let's get to the two types of semiconductor. There are two types of semiconductor. They are intrinsic semiconductor, extrinsic semiconductor. First intrinsic semiconductor. What is intrinsic semiconductor? A semiconductor in which holes and electron are created slowly by thermal excitation across the energy gap is called intrinsic semiconductor. A pure crystal of silicon or germanium is the intrinsic semiconductor. So, the pure crystal, it means only one atom are using in atomic bonds. So, the pure semiconductor is silicon or germanium. The electron reaching the conduction band due to thermal excitation are equal to the number of vacancies of holes in the valence band. Therefore, in the intrinsic semiconductor, the concentration of holes and electron must always be the same. The Fermi energy level for the intrinsic semiconductor lies midway in the Fermiton gap, where the probability in the finding on electron in 50%, even though there are no allowed energy level available at the position. In this semiconductor, the concentration of charge carriers increase exponentially with temperature. Particularly, these are not used once because their electrical conductivity is very small and it is not a constant one. And this is an intrinsic semiconductor atomic structure, and this is a pure semiconductor. The pure semiconductor is silicon, so we are using silicon. And this is a valence electron, and this valence electron, this valence electron, this valence electron. So this one is the valence electron silicon. So the covalent band or connector. What is the meaning of covalent band? Covalent band is the sharing of neighbor atom in valence band. So we are connecting in covalent band in intrinsic semiconductor. Next one, extrinsic semiconductor. Extrinsic semiconductor are two types, N-type semiconductor and P-type semiconductor. A material whose charge carriers originated from impurity atom is called impurity semiconductor or extrinsic semiconductor. What is the meaning for impurity? Impurity means the type of atom. Silicon and aluminum are joining in impurity. So in this conduction is mainly due to addition of impurity which increase the conductivity of a semiconductor. The phosphorus atom is set to the donor electron to the semiconductor, and this energy level of the fifth electron is called donor electron. So the phosphorus electron valence electron is 5. Since the elements such phosphorus, arsenic and antimony donate negative charge, negative charge means it's electron. These are called N-type impurity, and the semiconductor doped with them are it's called N-type semiconductor. Extrinsic of electron from the donor level into the conduction band takes place. Much more reality the across the energy gap from valence band. Each pentavalent from the covalent band with the adjacent silicon atom when a pentavalent 5 valence electron impurity are added. The donor level, what is penta? Penta means 5. So the valence electron is 5 valence electron. The donor level is not closed, and most of the donor level electron are excited into the conduction band in room temperature and becomes the majority charge carrier. The electron is a majority charge carrier. So in the N-type semiconductor, electron are majority charge. So the majority charge carrier in N-type semiconductor is electron, and the holes are minority charge carrier. So the minority charge carrier of electron, minority charge carrier consider the impurity like aluminum, gallium in semiconductor. Aluminum has 3 electron. 3 means trivalent. So 3 electron is outer shell, and the completer is bond is requires 1 more electron, that is supplied by semiconductor atom like silicon, thereby creating a vacant electron sit or holds the valence band in semiconductor. Since aluminum accepted 1 extra electron, the energy level is called accepted level, which is just above the valence band. So aluminum, gallium and they are all accepted impurity, and the semiconductors doped with the accepted impurity are called P-type semiconductor. So the majority charge carrier is P-type semiconductor or holes, since the most of the holes are free of conduction process at room temperature in P semiconductor. The majority charge carrier or electron in the P-type semiconductor, and like Intrinsic semiconductor, the concentration of holes and electron are unequal in extrinsic semiconductor. And N-type semiconductor, penta impurity phosphorus, arsenic, antimony atom is added to increase the number of conduction band is electron is in intrinsic silicon. Each pentavalence from covalent bond with 4 adjacent silicon atom when a pentavalent 5 valence electron impurity are added. So this will leave one extra electron without bonds and will become a conduction electron. It is not attached to any atom because the pentavalent electron gives a electron is called donor atom. Pentavalent elements normally used to doping process are antimony, arsenic, phosphorus, etc. A semiconductor is accepting a free electron, so it is a term acceptor. Extrinsic semiconductor are called N-type semiconductor. In N-type charge carrier or electron, so the electron is negative charge. And next type is P-type semiconductor. When a semiconductor material is doped with a trivalent having 3 valence electron, material 3 valence electron of trivalent element creating covalent bonds with the silicon atom nearby but it could not providing the fourth element, and this created a hole positively charged which is actually a vacancy and waiting for electron. So such doped semiconductor is called p-type semiconductor. In p-type semiconductor, the majority charge carrier are holes. So the p-type semiconductor is majority charge of holes. The holes mean positively charged. Example of trivalent element used the doping process are boron, gallium, aluminum, etc. The trivalent element is accepted here while the semiconductor is donor. Difference between N-type and P-type semiconductor. N-type semiconductor. N-type semiconductor, pentavalent impurity are usually is doping. So the pentavalent are using doping. The P-type semiconductor, trivalent impurity are usually in doping. So doping means the carry of electron and carry of holes. The impurity is called donor impurity. The P-type semiconductor impurity is called accepted impurity. So the negative charge is accepted. The N-type semiconductor, the electrons acts as a majority charge in carrier. So the N-type semiconductor is the electron is high, and the P-type semiconductor is holes are act as a majority charge carrier. So the P-type semiconductor is high holes are the majority of holes. So the number of counts is maximum in holes. In N-type semiconductor, conductivity is mainly due to electron which are negatively charged. The P-type semiconductor, conductivity is mainly due to holes with the positively charged. Extrinsic semiconductor, and this is a N-type semiconductor and this is a P-type semiconductor. And this is phosphorus and this is silicon, and this is phosphorus valence electron and this is silicon valence electron. So we are connecting in covalent band, and this is phosphorus second valence electron and this is third valence electron and this is fourth phosphorus valence electron. There are incomplete in atom shell. So we are completed. So we are waiting to the completed shell electron. So we are connecting in covalent band in silicon valence electron, and this is a pentavalent. The phosphorus electron is pentavalent. So the extra electron is this. The electron is a free electron. So this is the and this is the majority charge of this is semiconductor electron is act as majority charge carrier. and this is a p-type semiconductor. So the p-type semiconductor is using boron and silicon, and this is a boron valence electron, and this boron valence electron, this boron valence electron. Valence electron means the last atomic shell of valence electron. So this is the boron holes. So we are connecting on covalent band. So the p-type semiconductor, the holes are the majority charge carriers, and this is a covalent band, and this is covalent band, and this is covalent band. So this is phosphorus and silicon is combined, and this is boron and silicon is combined. So this is a impurity semiconductor. The impurity semiconductor is another name is extrinsic semiconductor, and this is an intrinsic semiconductor in our structure, and this is a silicon, and this is silicon. So they are using one and only atom. So this is a pure semiconductor. Uses of semiconductor, they are used in 3D printing machine. So the 3D printing machine are using in semiconductor, used in microchip and self-driving car, use and calculator, solar plate, computer and electronic device, transistor and MOSFET used as switch in electrical circuit or the manufacturing. So the semiconductor is one example is diode. The diode is one point is positive and one point is negative. So the positive point occupy the holes and negative point occupies the electron. So we are input is forward bias, you are getting in current output. They are the reverse bias, we are not getting in output. So the semiconductor pure semiconductor is the pure semiconductor is only using silicon, and impure semiconductor semiconductor, that is extrinsic semiconductor using phosphorus, silicon, boron and arsenic and antimony. Difference between type of semiconductor, the one type is intrinsic semiconductor and another one is extrinsic semiconductor. They are pure semiconductor, so they are using silicon only, and the extrinsic semiconductor is impurity semiconductor. So they are using phosphorus and silicon or boron or silicon. The phosphorus is 5 valence electron, the boron is 3 valence electron, and the intrinsic semiconductor density of electron is equal to the density of holes. So the electron and holes there is equal density. The extrinsic semiconductor density of electron is not equal to the density of hole. So the electron is high and the density of electron not equal to density of holes. Electrical conductivity is low, electrical conductivity high. Therefore depends on the intrinsic semiconductor depends on temperature only. The extrinsic semiconductor depends on temperature as well as on the amount of impurity. The intrinsic semiconductor, no impurities. The extrinsic semiconductor, trivalent impurity and pentavalent impurity. Trivalent impurity is example boron, and the pentavalent impurity is phosphorus. They are using silicon atom. And this is a difference between the intrinsic semiconductor and extrinsic semiconductor. Next, importance of semiconductor. Importance of semiconductor in modern technology. Semiconductor are considered the brain of modern electronics technology. The importance of semiconductor make its availability in various technological electronic device including transistor, microchip, solar plates, planets and many other LED or LCDs displaying device. Main sector of semiconductor. All electronic devices, either small or big in size, have semiconductor microchip. It is present in your hands in the form of your mobiles and the internet, as well as the similarity it has used even in your steering wheels of the car or other vehicles. Here, the other will discuss the main sector in enthusiasts in which these microchip semiconductor are being used for the comfort of user. Telecommunica- telecommunication sector, and second one is banking sector and home appliance and security camera, healthcare gadget, transportation sector and manufacturing sector. From this we know what is semiconductor and what is some type of semiconductor and what is uses of semiconductor and importance of semiconductor. Thank you.